Alright, what up dudes? Here's what we're going to be doing. We're going to be taking a look at the end behavior of this thing right here. And we've already talked about how this thing has a vertical asymptote. This thing has a vertical asymptote at x equals -2. So here's our vertical asymptote, dot, 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 dot. And it goes up to infinity and down to negative infinity. But if you look at the graph, and you look at where this thing goes as it goes all the way out. So actually what we looked at is when x gets really, really close to this number over here and when x gets really, really close to this number from that side. But what we haven't looked at is what happens when x goes all the way out to infinity on that side and x goes all the way out to negative infinity on that side. What does the y value happen to be? Well, if you think about it, if x becomes a really, really, really big number, then you're going to have 1 over x plus 2. And to be honest with you, a really, really big number, like 1 billion and 1 billion and 2, is almost the same. So we kind of, like I said, we disregard everything below this. We only take the leading coefficient. It's kind of like, what's the difference between a billion and a billion and 2? Like if I had $1 billion, would I be not unsatisfied unless I had $1 billion and $2? No, you can have your $2. I'll keep my billion. You know what I mean? Like it doesn't really matter. The 2 I can just scratch off. I only really care about the thing out in front. All right, so we know that the thing is going to kind of look like that. And if x gets really, really big, if that number gets really, really big, what's going to happen to that thing? It's going to have a number divided by a really, really big number. So like, for example, if I have 1/2, and I have 1/5, and I have 1/10, and I have 1 over 100. Actually, when the denominator gets really big, the fraction overall, like 1/2 actually is bigger than 1/5. And 1/10 is even smaller, and 1/100th is even smaller. So 1/1 billionth, or even like 1 over infinity, or something close to it, or really big, is going to effectively go to 0. Like it's going to be so small, it will be 0. And so you actually kind of taper off. And so what this creates for us is this, we talked about a vertical asymptote, but now we actually have a horizontal asymptote. Because it never actually reaches 0, but it really gets close to it if you get x equals really, really big numbers or really small numbers. All right, so let's take a look at this thing. We know that there's going to be a vertical asymptote over here at x equals 4. And we also know that there's a horizontal asymptote. The horizontal asymptote happens when x gets really, really big. And it's going to look like the horizontal asymptotes that 1 over x has. 1 over x, the graph looks like this. Here's the x coordinate, here's the y coordinate, and that graph kind of goes down over here and over here like that. So I'm betting that this graph is going to do the same thing. And like I said, with this end behavior games, I don't really care how it looks in the middle. I just want to know how it's going to look towards the end on this side or this side of the equation. And if I were to graph that on Desmos, 1 divided by x minus 4, you can see that's exactly what that would look like. Let's see if we can get a few more of these in here before I stop the recording. Do I want to do any of these? Alright, let's try this one. Okay, so what's going to happen? Actually, you know what? I think that I'm going to stop the recording. No, let's keep it going. Alright. So what's going to happen over here? Okay, what we're going to look at is, we know that there's a vertical asymptote at x equals 1. You can tell by looking at that thing right there, the denominator. As far as a horizontal asymptote goes, if x gets really, really big, then effectively this plus 3 doesn't matter, right? Like if x gets really, really big, I can kind of disregard that really big number, or the 3, because that's just a constant number being added to something that's going to infinity. And if x gets really, really big, I can kind of disregard that -1. So it's x over x. So what's going to happen is x divided by x is equal to 1. So what's interesting about this is this thing is going to go to the horizontal asymptote where y is equal to 1. So I'm guessing that the graph is going to look something like this. Let's take a look at it and see what happens. Let's see. X plus 3. Oh, x plus 3. Oh. X plus 3 divided by x minus 1. Ah, there we go. See? You see, it happened exactly the way I thought it would. Look where the horizontal asymptote is, too. It's at y is equal to 1. It's going to, as it goes out to infinity in the positive direction and down to infinity in the negative direction, it's going to go closer and closer to this horizontal asymptote, this 1 value that we're kind of getting close to.